Why is it always fractals and psychedelic trips? And what does this mean? I'm Zeus Tipado, a psychedelic neuroscientist researching out of the Netherlands. And before we go on into seeing fractals and psychedelic trips, I need you to like and subscribe to my channel because I'm trying to blow up. Throughout psychedelic history, across cultures, across centuries, people have reported seeing geometric patterns. And these aren't random, they're remarkably consistent. The same spirals show up in ancient cave paintings and medieval mystical visions, in 1960s acid art, and in modern DMT trip reports. But these patterns also show up in migraine auras, near-death experiences, sensory deprivation, deep meditation, even just pressing on your eyelids. Which means fractals don't reside within psychedelics. Seeing fractals is fundamental in the construction of your brain. But first, what are fractals? In 1958, a Polish-born mathematician named Beno Mandelbrot was working at IBM's research center when they asked him to investigate a problem. Their electronic transmission lines had noise, seemingly random interference that was disrupting signals. Mandelbrot started analyzing this noise, and he noticed something strange. The noise appeared in bunches, patterns that stayed consistent whether he analyzed them by the minute or by the hour. There was structure hiding in what looked like chaos. This observation became his life's work, and in 1975, he published a book that would change how we understand nature itself. He called it Fractals. The word comes from the Latin fractus, meaning broken or shattered. And what Mandelbrot discovered was a new kind of geometry. Not the smooth circles and perfect lines of classic geometry, but the rough, irregular, infinitely complex geometry of the world. Basically, fractals are patterns that repeat at every scale, zoomed in or zoomed out. Think about a tree. The trunk splits into branches. Those branches split into smaller branches. Those split into twigs, same pattern, just at different scales. That is a fractal. Or look at broccoli, specifically Romanesco broccoli. The whole head looks like the individual florets, and each floret looks like even smaller florets. It's the same shape, repeating infinitely. This is the fractal dimension. Classic geometry deals with integer dimensions. A line is 1D, a square is 2D, a cube is 3D. But a fractal, it's not quite 1D like a smooth line, but it's not 2D like filling a plane. It's somewhere in between, like 1.25 dimensions. Fractals exist between dimensions. And once you know what to look for, you'll see fractals everywhere in nature. Tree branches, leaf veins, river networks, lightning bolts, coastlines, mountain ranges, cloud formations, your blood vessels, your lung structure, your brain's neural network. Fractals are nature's solution to maximizing surface area with minimal volume. Your lungs need maximum surface area for gas exchange. Trees need to reach maximum sunlight with minimal structural material. Rivers need to drain maximum area. Fractal patterns emerge naturally. And your brain is fractal too. Neurons branch in fractals. Brain regions organize in fractals. Even brain activity follows fractal patterns across time. Which brings up the next question. If your brain is fractal, what happens when you trip on psychedelics? In the 1920s, way before the invention of LSD, a German-American psychologist named Heinrich Klöver was conducting experiments at the University of Minnesota. He and his research assistant were taking mescaline, peyote, in the lab and carefully documenting what they saw. And Klöver noticed the patterns they saw were repeating across different sessions, across different subjects. The same geometric shapes kept appearing. And in 1928, he published his findings. He called these repeating patterns form constants, and he organized them into 4 categories. The first category, lattice, checkerboards, honeycombs, triangles, filigree patterns. Second category, cobwebs, interconnected web-like networks. Third category, tunnels and funnels, spiraling vortices that you feel like you're traveling through. Fourth category, spirals, rotating, expanding, contracting patterns. These patterns appeared regardless of individual differences, regardless of set and setting, regardless of whether people had seen them before. Klöver realized these must reflect something fundamental about how the visual system is built. And he was right, because these same patterns don't just show up in mescaline, they show up in LSD, on psilocybin, on DMT, on cannabis at high doses, in migraine auras, in epileptic seizures, during sensory deprivation, even when you press your closed eyelids. The patterns are built within your neural hardware. But let's talk about how fractals appear in your psychedelic trips. Let me walk you through a typical psychedelic experience timeline. Around the 20 to 40 minute mark, colors get brighter, surfaces start to shimmer. Close your eyes and you might see faint patterns like visual static, but more organized. These are the earliest form constants emerging. And around the first to second hour is where it gets intense. Close your eyes and you've been plunged into a geometric universe. Simple lattices evolve into complex tunnels and spirals. You're traveling through fractal spaces, each containing infinite detail. The patterns are self-transforming, kaleidoscopic, impossibly intricate. People often describe this as more real than reality. Mathematical perfection made visible. Sacred geometry, the architecture of the universe itself. And then eventually, if you open your eyes, the geometry overlays everything. Wood grain becomes infinite fractals. Carpet patterns breathe and morph. Faces appear everywhere. That's extreme pareidolia, which we'll talk about in a minute. Now, of course, different substances have different qualities. This was a combination of a lot of psychedelic experiences. LSD tends to be more crystalline electric geometry. Psilocybin has this organic Aztec-like quality, often described as living geometry. And as far as DMT is in its own category. It compresses this entire timeline in a few minutes and produces the most complex, alien, hyperdimensional fractals possible. But they're all the same basic patterns, different drugs, same geometry. Why? Because the drug doesn't create the geometry, it reveals the geometry that's already built into your visual system. So exactly how does your brain generate fractals when you trip on psychedelics? At the back of your brain, in your occipital lobe, is the primary visual cortex, also called V1. V1 is where visual information from your eyes first arrives in the cortex, and is organized in a very particular way. It's laid out in repeating modules called hypercolumns. Inside each hypercolumn are orientation columns. These are groups of neurons that respond to specific line orientations. Some neurons fire when they see horizontal lines, others fire for vertical lines, others for diagonals. And these columns are arranged in a beautiful geometric pattern called a pinwheel structure. When you hallucinate with your eyes closed, you're not seeing much external input. You're seeing the back of your eyelids, the spontaneous activity of your visual cortex. The geometry you see reflects the geometry of how V1 is wired. But the way your retina maps onto V1 isn't a simple one-to-one correspondence. It's distorted, like a fisheye lens. The center of your vision, your fovea, gets massive representation in your V1. The peripheral gets compressed. This is called cortical magnification. So when patterns form in V1, they have to be transformed through this map to create what you actually see. A stripe pattern in V1 becomes something very different in your visual field when you apply this transformation. And this is the key to understanding form constants. In 1972, a mathematician named Jack Cowan and his graduate student named Bard Ehrmantraut built the first computational model that could explain a geometric hallucination. Here's the basic idea, and I'm going to keep this conceptual, not mathematical. Your V1 has two types of neurons: excitatory neurons that activate their neighbors, and inhibitory neurons that suppress activation in their neighbors. These are connected in a specific pattern. Excitation spreads quickly across short distances, and inhibition spreads more slowly across longer distances. Normally, V1 is in a stable resting state, relatively quiet. But psychedelics push V1 towards an unstable state, and when the system becomes unstable, spontaneous patterns emerge. These aren't random. They're constrained by the architecture of the brain. And here's where it gets beautifully complex. An excited neuron strongly inhibits its neighbor. Those neighbors themselves are inhibitory neurons. So inhibiting an inhibitory neuron means less inhibition, which means more excitation. This creates a spreading wave of excitation, but the wave has structure. It follows the geometry of the excitatory and inhibitory connections. The result? Stripes and patches of activity in V1. Now apply the retinocortical map. Transform those V1 patterns into visual field space. And suddenly, stripes in V1 become lattices and honeycombs in your visual field. Concentric rings in V1 become tunnels and funnels. Rotating patterns in V1 become spirals. This is exactly Clover's form constants. The math works out perfectly. Trip reports consistently mention that geometric patterns seem smaller and more detailed in the center of vision, and larger and more sprawling in the peripheral. Why is that? Because of receptive fields. Each neuron in V1 responds to a patch of visual space, its receptive field. In foveal V1, those are tiny. In peripheral V1, those are large. You're literally seeing the architecture of cortical magnification when you notice geometry getting bigger towards your visual peripheral. Okay, this explains simple form constants, but what about the incredibly complex patterns that psychonauts report? The elaborate, impossible geometries? This is where higher visual areas come in. V1 generates the basic patterns, but these patterns are propagated to V2, V3, V4, higher visual areas that process more complex features. Actually, recent research shows that under LSD, connectivity between visual areas become more dependent on retinotopic structures. Areas that process the same parts of the visual field become more connected, and areas processing different parts become less connected. So the simple patterns generated in V1 get elaborated into higher visual areas, but the elaboration still follows spatial structure. So that means you don't get random complex images, you get geometrically organized complex images. Fractals within fractals within fractals. But when you're tripping on psychedelics, it's not just that you see fractals when you're tripping, your brain becomes more fractal. A 2020 study by Thomas Varley measured the fractal dimension of brain activity under psilocybin and LSD. They looked at two things: the spatial structure of how brain regions connect to each other, and the temporal structure of how activity changes over time. Both become more fractal on psychedelics. Now what this means is the structure of brain activity itself takes on fractal properties. This happens at multiple scales. Connectivity networks become more fractal, activity patterns become more fractal, and probably molecular processes also become more fractal. You're not just observing fractals in your visual field, your entire conscious experience is becoming fractal. When you're tripping, you're seeing your own brain's fractal structure projected into visual space. And why did evolution build fractal brains? Because of efficiency. Fractals maximize connectivity with minimal wiring. With 86 billion neurons, you can't connect everything to everything. Fractal organization, local clusters, hierarchical structure, achieves high connectivity with minimal wire length. It also enables multi-skill processing. You need to see edges and objects and scenes simultaneously. Fractal architecture makes this possible. Nature converged on fractals everywhere because fractals solve problems efficiently. So when you're on psychedelics seeing these geometric patterns, what are you actually experiencing? You're not hallucinating in the sense of made-up nonsense. You're seeing the computational structure of visual consciousness, the mathematical architecture that constructs your everyday perception. Many users interpret this as sacred geometry, evidence of higher dimensions, the underlying mathematical structure of reality, proof of intelligent design. And you know what? Maybe the brain is fractal because reality is fractal. Maybe consciousness is structured to mirror the universe's structure. Or maybe we project our brain structure onto our model of reality. Neuroscience only tells us the mechanism, not the meaning. And you can appreciate both. Understanding how your brain generates these patterns doesn't make them less profound, it makes them more profound, because you're directly experiencing the architecture of your own consciousness. And that is the end of this episode. If you want to support this show, then join my Patreon and get exclusives right there. Join! I hope you enjoyed this episode of Your Drug on Brains. Be sure to like and subscribe, leave a comment, I read all of them, and follow on X, TikTok, and Instagram, all at Tipado. Thanks for watching. I'll see you next week.